Okay, so the second part is talking about the graphs of reciprocal functions, and we're going to sort of zoom through this a bit. This is meant to be an investigation, but we're sort of doing 2 days in one today. So you just watched video for day one. Now we're actually on the video on day two. And so instead of giving you time on your own to investigate, we're going to investigate together as you watch the video. So we're looking at reciprocal functions. We just finished talking about the idea of division in functions as opposed to multiplication. So in grade 9, you did stuff like 18 times x, and then the example we just looked at was 18 divided by x, and how the graph looks different. Even though they look very, very different, it turns out there's lots of similarities, and hopefully we'll notice the patterns as we go through this investigation. So the first thing we're going to look at, y equals x, so we know it's a linear function. We're actually talking about 1 times x, but we're going to compare it to the 1 divided by x. But first we'll start by graphing the y equals x. So of course, and as you're going along, this is going to go pretty fast, so if you don't have enough time to get a picture done, that's okay. Just sort of watch, and you can have time to finish it afterwards. Sorry about that. I just got interrupted by a basketball player of mine, and you know how those basketball players are such pains. So back to what we were saying is we're going to have time to look at these. Hopefully you'll be able to follow along and keep up. If not, don't worry. You can just listen and get the idea and complete your pictures afterwards. But we'll just start with the linear function there. We know that y equals x, so all the numbers are the same, and it produces a straight line. Done. So what does 1 over x look like? Well, we'll start actually with looking at 1. So if x equals 1, this becomes 1 over 1, which is just 1. When x equals 2, it's 1 over 2, which is, of course, a half, and then 1 over 3, and so forth. Same thing in the negatives. This would be negative 1, negative 1 over 2, and negative 1 over 3. What about 0? Well, of course, 1 divided by 0, not allowed. So we end up with an x there that doesn't exist. So I'll start graphing these points. So 1, 1 is right here. 2 1/2 is about there. And 3 1/3 is getting about there. What about negative 1 and negative 1 is there. Negative 2 and negative 1/2 is there. And negative 3 1/3 is roughly there. Then we have the idea of plus or minus 1/2, so of course we'll have plus for one side and minus for the other one. This right here, this is 1 over 1 divided by 2. Well, how do you divide fractions? You multiply by the reciprocal, so it's 1 times 2 over 1, and so that's just 2. So 1 over 1/2 is 2. 1 over 1/3 is 3. 1 over 1/4 is 4. And if it's negative, then you end up with the same side, the same thing, but in the negatives. So let's go off and graph this. If it was a positive 1/2, 1 over 1/2 is 2. 1 over 1/3 is 3. And then we get closer and it starts to get really crowded. Same thing with the negatives. And of course, we know the shape of this here. It goes like this. I'm going to try and exaggerate that I'm not touching that curve, even though it's a little challenging here on the smartboard. I'm not touching that edge. Okay, we know this. We've already sketched this once this year, so we're pretty comfortable with this function. But what do we notice? So let's fill in the blanks here. So when y equals x is at 0, so when y equals x is at 0, right here, what happens to the reciprocal? So the 1 over x. Well, what happens at 0? Well, you flip it, and it's 1 over 0, which is not allowed. And so we have this imaginary line here where no x or y exists. That, of course, has a name. It's called an asymptote. Oops. 1s. An asymptote. Try not to giggle too much. Okay, then let's look at the original. When y equals x is positive, what is 1 over x doing? So here, over here, these are all positive values. Well, what about in the positive values over here? Well, of course they're positive, because regardless, if you take a number and divide it, if it was positive, it's still going to stay positive. And vice versa, if it's negative down here, if you take the reciprocal of a negative number, you still end up with negative numbers. It doesn't change the sign. All right, now let's consider what happens when the graph is increasing. So this graph, the whole graph is increasing. It's always increasing. Well, what happens when you take the reciprocal of numbers? So if the numbers go 1, 2, 3, 4, 5, and they're increasing, the reciprocal is 1 over 2. 1 over 1, 1 over 2, 1 over 3, 1 over 4. Those numbers get smaller. And you look at this graph, these numbers are always getting smaller. Even these ones are all getting smaller. So when the original increases, the reciprocal decreases. Oops. Decreases. And vice versa. Well, we don't have an example here where we have it decreasing in the original, or in looking at the reciprocal. We'll look at that in a second. What about when y equals x is at 1? Well, guess what? At 1, you end up with 1. What's the reciprocal of 1? 1 over 1, which is just 1. So these points still stay the same. So when the original is at 1, the reciprocal is still also at 1. Vice versa, or same with the negatives. If it's at -1, the reciprocal is -1. All right, looking at the original. When the original has a y-intercept, well, what's the y-intercept of this one? The y-intercept is 0. The intercept of the reciprocal is 1 over 0, which doesn't exist. So not too exciting when looking at the intercepts, the y-intercept. It might in other functions. And notice the last one, the graph here also not only has this vertical asymptote, but there's also a horizontal asymptote in the range. So y equals 1 over x has a horizontal asymptote at y equals 0. Why is that? Well, as x approaches infinity, as x approaches positive infinity, y approaches 0. Gets really, really close to, but doesn't touch. We know this. We looked at it in the last video. We already knew this before. And of course, the same thing happens in the negative infinity. So it approaches but never touches. That's the definition of an asymptote. So it's interesting. We have a couple of these things that we've noticed. Let's see if these patterns hold true when we look at the second one.